Today we're beginning our unit on forces in motion. First of all, a force is a push or a pull that acts on an object. It doesn't matter if you push a chair across the room or if you pull it across the room, it's still the same force. Force is a vector. It has both a magnitude and a direction. So it has a magnitude, an amount, how big the force is, and the force is always exerted in some certain direction. If you push the chair away from you is your direction. You can show this direction with an arrow. Also, since forces are vectors, they can be combined by vector addition. Remember, that means if the forces are in the same direction, you add them, and if they're in opposite directions, you subtract them. Weight is the force of gravity on an object. That's how much the Earth pulls down on an object because of its mass. Mass is the amount of matter in an object. It's how much stuff is inside the object. So let's talk about how you measure each one. Mass is measured with a balance. A balance balances out the weight with these weights on this side. So we move this weight until it balances out the weight over here. If you go to the moon, this balance will give you the same mass because the amount of matter here and here have not changed, and they still cancel out. However, the weight on the moon will be different because there's less gravity on the moon. Weight is measured with a scale. This is a spring scale, and when the weight is hung on it, the force of gravity pulls and stretches this spring, and you get the weight of your object. On the moon, there's less gravity, there's less force pulling down, and the weight would be about 1/6 of what it is here on the Earth. Mass is not only the amount of matter in an object, it also measures the object's inertia, which is its resistance to changes in motion. The heavier something is, the harder it is to get moving. Or the heavier something is, the harder it is to stop it from moving. That's inertia. If it's sitting still, it stays still. If it's moving, it tends to keep moving. Mass is measured in kilograms, but force is measured in newtons. Now you're used to using pounds, but we need to get used to using newtons for force. The way I remember that is that Cam Newton has a lot of force when he is playing football. Or I remember that fig newtons sounds like force newtons, fig newtons. I don't know, it helps me remember. One type of force is gravity. Another type of force is friction. Friction is a force that opposes the motion of the object. Whichever way you're trying to move, friction is pushing back the opposite way. Let's take a look at the 4 types of friction. One type of friction is rolling friction. In order to keep this cart rolling and moving across the floor, I must exert enough force to overcome the friction between the wheels and the floor, and between the wheels and the axle. I can pull, and now friction is trying to pull this way. When I was pushing forward, friction was opposing my motion and pushing that way. Another type of friction is sliding friction. If I try to slide this cart across the floor instead of rolling it, that's sliding friction. It's a lot greater than the rolling friction because it's a lot harder to scrape it across the floor than to roll it across the floor. Another type of friction is static friction. This is the friction that must be overcome to get an object to start moving. Have you ever moved a big piece of furniture? And did you notice it's harder to get it moving than it is to keep it moving? That's static friction. So I have to give a little extra shove to get the cart moving, and a very gentle, light shove to keep it moving. It's the same way with this chair. In order to get the chair moving, I have to exert more force, and to keep it moving takes less. The next type of friction is fluid friction. Most people know that liquids are fluids, but a lot of people don't realize that gases are fluids as well. A fluid is anything that flows. And if you think about the air, when it flows or blows, that's fluid. So you can have air resistance is one type of fluid friction, or you can have water resistance or some other liquid resistance. Have you ever tried to run through a swimming pool? Oh my goodness, it feels like you're just slogging against that water. That's fluid friction. Have you ever been in a car and stuck your hand out the window and you feel the push of the wind? That's the air molecules hitting your hand and causing fluid friction. Let's rank the 4 types of friction from greatest to least. Which type of friction takes the most force to overcome? Think about that for a minute. The greatest type of friction is static friction. It's harder to get something moving than it is to keep it moving. So this is your greatest friction. The second would be sliding friction. It's harder to push something across the floor than it is to roll it across the floor. So sliding is second and rolling is third. Fluid friction can be greater than any of these other types, or it could be less or somewhere in the middle. We're going to assume that the objects we're looking at aren't moving super fast, so fluid friction would be the lowest friction.